super, es funktioniert, 14 Uhr. Also die Zeit anzufangen. Ja, ich habe versucht, euch zu zeigen, dass ich die Slides auf Twitter veröffentlicht habe, was leider wegen der lokalen WLAN nicht funktioniert, aber es ist nicht so schlimm. Das ist mein Twitter-Nick, wo ihr die Slides einfach findet. Mein Name ist Peter Palaga. Ich spreche zufällig Deutsch, weil ich einige Jahre in Leipzig und Berlin gewohnt, gearbeitet und studiert habe. Aber den Rest des Vortrags werde ich lieber auf Englisch halten, weil ich es so meistens mache und es ist einfacher und sicherer für mich. So, I work for Red Hat. I'm an engineer. I'm assigned to a product called Red Hat Fuse. Red Hat Fuse is basically the same thing as Apache Camel, with the significant difference that you can buy a support from Red Hat for Red Hat Fuse. Apache Camel, who of you knows Apache Camel? Oh, so many. So it's an integration platform for the others that is there to allow communication between systems that were not designed to communicate with each other. I'm currently spending the most of my time in a project called Quarkus, and it basically means porting Apache Camel components to Quarkus, and that's basically my relationship to Quarkus. I'm not a part of the Quarkus core team, but I'm working daily with Quarkus, porting the Camel extensions, Camel components. Those are basically things I was paid for. I'm paid for currently. In the past, I was paid for fixing bugs in JBoss EAP and Valfly. In my free time, I like hacking in build tools such as SourceSteps. I had a SourceSteps talks last year on this conference, maybe you remember me. And my other pet project is editor config for Java. A very simplified summary of this talk could be that it consists of an 8 milliseconds demo and 45 minutes of explanations what happened in those 8 milliseconds. I hope I will be able to explain to you what is Quarkus, how it works, and in the end, depending on how much time is left, I'll guide you through some interesting Quarkus features. So let's try the demo. I have prepared a simple Hello World project here. I have compiled it before because it takes about a minute, and I didn't want to bore you straight ahead at the beginning. And this is the result of the compilation. There's a file that has no extension, and it has no extension because it's Unix executable. It's just 19 megabytes big, and it's a REST application with a single REST endpoint written in Java. It's pretty small for Java, right? 19 megs. Let's start it. Could you see how fast it was? Once again. And once again. And once again. Eh? Can you see this number? For a Java application, right? So maybe you have seen something like this during Adam's presentation yesterday. Let's try if it works. it works. Let's check how much memory does it spend. It spent this many megabytes of memory, 16 megs, for a Java application, right? A simple one, but anyway, 16 megs. Isn't it great? Yes, this. So, that's the motivational demo. And now, let's go on to the explanation how this is possible. So first, what is Quarkus? It's a toolkit in the first place, and it's a little bit of a framework for writing Java, Kotlin, and Scala applications. If I say that it's a toolkit in the first place, this is the reason. This is how it comes into the workflow of a stock Java web application developer. It's there basically only as a Maven plugin, right? And that's it. The input for the Maven or the plugin is compiled Java code, either in form of classes, jar files, and those are transformed into something which we call now, or here, optimized jar. The jar can be run either on a stock JVM, such as OpenJDK, using hotspot, or it can be further processed using GraalVM to produce the native executable I have shown you at the beginning, right? This is the most important thing you need to remember about Quarkus. It's a tool for building applications, and it has two modes, the JVM mode and the native mode. JVM mode is fast. The things work there as usual in Java. It's fast to build, that's what I mean. The GraalVM takes longer to build, but produces an even more optimized native executable that is very small and fast to boot and takes very few memory. So, if Quarkus is primarily a toolkit, you may ask yourself, how am I supposed to write my programs? Am I supposed to model the request, model the response, and write everything from nuts and bolts? No, because Quarkus is embracing existing standards. And if you know those standards, if you used them before on some other platforms, then you basically know how to use Quarkus. And those are the well-known old Java EE standards, such as Servlet and JAX-RS for REST endpoints, JPA for persistence, primarily using Hibernate, CDI, validation transactions, logging, and so on. There are also all the new microprofile standards supported, such as fault tolerance, health, Java Web tokens for role-based authorization metrics to be able to to let Prometheus pull the metrics, Open API, Open Tracing using Jaeger, reactive messaging for Kafka, AMQP, MQTT, REST client, and so on. And there's also Spring. And the last two of those are very, very new. They came with the last release like 2 weeks ago. Those are reached, or the support for those is reached through a compatibility layer, which basically means that the annotations from the Spring packages are mapped to annotations or mapped to functionalities available in the implementations that we have for Java EE. And this is basically there to allow Spring developers to jump in very quickly, because you don't need to learn new things. Most of the annotations known to you should work out of the box as expected, and naturally some corner cases are not going to work, or perhaps they are going to work differently, but if you spot something like that, please file an issue on GitHub on the Quarkus project. Good. Except for the standards and de facto standards like Spring, Quarkus offers support for many well-established libraries and frameworks. There's Vertex for reactive programming, there's Native for low-level network access, and there's Apache Camel. That's exactly what I'm doing daily, my bread and butter. And here, on the new Apache Camel website, you can check how many components we have already ported. This is the list. Okay? There's Infinispan client for the distributed cache. There's Caffeine for local caching. There's Keycloak for the identity management and security. There's support for the Kubernetes client, and the Quarkus plugin produces some configurations for Kubernetes and OpenShift. We strive hard to make Java usable, Java using Quarkus usable as a language for cloud functions, either AWS Lambda or Azure functions. I don't know how well it works at the moment, but there are really people working hard on this, and this is supposed to work either now or soon. So if you try this and find something that doesn't work well for you, please file an issue. Okay? Apache Tika for reading various formats, Elasticsearch and Cogito, that's a new umbrella for JBoss rules and business processing. Okay, are you missing something? Yes, databases. So there's support for MySQL, MariaDB, Postgres, the usual suspects. H2 for testing, lightweight database. There's out-of-the-box support for Microsoft SQL Server. I don't know if Oracle is coming, but perhaps, because as you may have seen recently, like a couple of days ago, Oracle finally released their driver on Maven Central. Great. Good. There's Flyway support for schema migrations. There's support for Amazon DynamoDB, MongoDB, Neo4j, the graph database. Very nice. Good. Quarkus allows you to use both the traditional imperative and the reactive style of programming within the same application, where the reactive part is powered by Vertex. Quarkus was designed with the aim to offer a lot of developer joy. It is very easy to start with. So first, you can use the Maven plugin, and that's what they use on the Quarkus website, this one. If you go there and go through any of those guides there, for example, something easy, configuration, this is basically what you will see there. They tell you to use the plugin, and that's how it produces a simple project for you, where you add things that are covered by the guide. So the tool just creates a simple project with all those dependencies set and so on. Or you can use the new code.quarkus.io, which is there since a couple of weeks. Let's try it. Let's get a simple application with a REST endpoint, like this. Let's unpack it here. Oh, I have unpacked it already. Sorry, let's delete the old one. Once again, extract. And what it contains is a stock Maven project with the BOM imported that manages the versions you need, because we selected just REST. It contains just RESTEasy, the implementation for JAX-RS there, and 2 test dependencies. The runner for JUnit 5 and REST assured for testing REST endpoints. There's just a single Java source file that should look like a stock JAX-RS resource to you. There's nothing special here. If you code it for Wildfly, EAP, or whichever other Java EE container before, this is basically it. That's the same thing. Okay, this is how you can start. There's live reload. If you tend to work with JavaScript, you maybe know something like this with NMP. And what this basically does is it compiles the application, and it failed because I haven't killed this one. Let's kill that one and try it again. So what it does, it compiles the application and starts a process that watches changes in your workspace. And if there is a change, that doesn't compile straight ahead. It waits until you send a request. And when you hit the endpoint, or whichever way you are supposed to communicate with the application, it can also be an AMQ message or Kafka message or whatever you send there. It will recompile and reload the application. And it is pretty fast, as you will see. So let's change this to hello JCON. I hit save, nothing changed here. And if I go to this one, I didn't want to close it, sorry. Localhost, it shows JCON. And I wanted to show here that it has recompiled in between. Let's do something more complicated than changing a string. Let's add string greeting. Yeah. What's wrong? Doesn't show me any hints. Oh, I'm not able to code without help. How would I do it? For some reason, the Java plugin is dead. It's not there. let's Google. So it's MicroProfile config. This is not fast enough, I'm sorry. Quarkus, the guide was there. The configuration guide like this. So this is what I'm looking for. I hope it's going to be able to resolve the property. No suggestions, it will not work. I'm sorry, but I can actually show you what happens if there's an error in the application. So I'll hit refresh and it shows me the error, right? So let's try to restart the code. Maybe that's the Microsoft way of doing things. Example, config property. Oh, it's showing something. Oh, finally. Terminal. Maven Quarkus dev. Let's call it demo message. Let's add a default volume, which will be nach. And we'll replace this one with the greeting. Okay, I hit save. And it should be able to reload. The JCON, it's there. Very nice. Let's add something more. Let's add a query parameter name. Query parameter JAX-RS one name string, and this will not be JCON but name. I hit save. Nothing happened. I go back here, hit refresh, and it will show me now because I haven't supplied any parameter. Let's say Joe. And it's Joe. Okay, very nice. You code, hit the endpoint, and all the compilation is done for you. It also starts a debugger at the background, so you can just connect to the debugger and debug whenever you need on the port 5005. Let's go back to the presentation when we find it. Localhost. On which port did it run? On... Oh, no matter. Let's start again. So... hop. What is Quarkus? Developer join. Yes. There's support for not only Java but also Kotlin or Scala. Scala is actually not there yet, not released, but it's in the master. And actually, I think they were supposed to release today. So if they release today, Scala will be there. You can choose also Gradle. As far as I know, the Gradle support is a bit behind. And if you see an issue, please file a bug on GitHub issues. There are runners for JUnit 4 or 5. Let's check what it looks like. The code Quarkus.io project generator has produced this single test that just hits the endpoint and expects hello. And because we have changed the endpoint, it will fail, I hope. Yes, it failed because nach null. That's not what we want. We want hello, name is. Oh, that will not work like that. I will have to. So let's just expect what it says. Nach null. And pass. I'm doing it again so that you see how fast the test execution is, roughly. Okay, 5 seconds. This is okay for running tests, and those tests are run just in the JVM mode. There's also a way to to run the native tests. This annotation means JVM mode, and this other annotation means native mode. And as you can see, the native test just extends the JVM test, so that you don't need to re-implement all those scenarios again. I can actually show you how to produce the native executable. MVN clean verify so that the native tests are run. Oh, there's no code completion. This is what I need. The native activates the profile that is there in the POM.xml file here at the bottom, and the profile just adds the goal that runs GraalVM on top of, or that supplies the jar to the GraalVM, and GraalVM produces the native image. This second parameter is there to use Docker instead of locally installed GraalVM. It's there for your convenience, because pulling Docker image is most of times easier for you, because you don't need to care for versions of the GraalVM and install it and so on. So this just pulls the right Docker image, and there's GraalVM inside the Docker image, and it runs the build inside that Docker image using your local Docker installation. So I will just start this, and we will not wait till it finishes, because it takes around a minute. So first the JVM mode tests were run, and this is the native image compilation. Let's go back to the presentation. And Quarkus isolates you very nice from the GraalVM CLI and API. As you could see, I have basically done nothing else than activate a Maven goal inside the POM. That's it. I don't need to know anything about the options and quirks that are necessary to make my specific application running on top of GraalVM. So that was about developer joy. Why are we doing this? Because we want to run Java inside a container, or perhaps also as a cloud function. And for that we need small size on a disk, so that we have small containers that are easy to deploy and easy to push and download. We also need fast boot time, especially in the cloud functions environment. If this Java native executable is able to start in 3 milliseconds code, That's great. You don't need to care about cold or hot starts. It's all the same. It's a couple of milliseconds difference, right? And the low memory footprint is very, very important. So, and when we are speaking about the sizes and runtimes, let's have a look first how we measure. So you have seen me to issue a command like this at the beginning, and what it basically does is to check the resident set size memory. What's that? That's the amount, the whole amount of memory used by the process, in our case, the native executable process. Because in Java you may well know heap size and things like that, but that's not all what the Java process needs to run. And especially when you are setting limits in Kubernetes, you need to know what the whole JVM process needs, or the native process needs to run. So this is the measure that is important in this area. So, and this is a small comparison what it looks like when we compare traditional cloud native stack, and it doesn't matter much if we take Spring Boot or Wildfly or EAP or whichever modern container. The numbers will be somewhere around this order of magnitude, right? You probably haven't seen a Spring or Wildfly process to be under 100 megabytes, right? Never. Never. Simple Java command line hello world takes like 100, I don't know, but it's a huge process that needs lots of RAM. So Quarkus, even in the JVM mode on OpenJDK, for the simple REST application like the one I have shown you in the beginning, is able to run with the half, roughly the half, compared to the traditional Java cloud native stacks. And the native executable is 1/10 of what you had originally. Let's add JPA, the persistence to it, to the mix. And the numbers look basically the same. It's a little bit more, but still the difference is huge even in the JVM mode. Okay? So, and the boot time. The first thing when speaking about the boot time is that modern containers cheat a lot because they use lazy initialization. And on the console, they report to be started even before they have initialized all the classes that are needed to serve the requests, right? So the measure that is meaningful for us is the time to the first request. That's the time needed from starting the process to your request being really served. How can we measure something like that? It's very easy. We just add a simple print line with current time milliseconds at the beginning of your endpoint or handler. Then we start a loop that sends the requests to the endpoint every, what is this, nanoseconds or 10 nanoseconds. And then we, in the single command, we echo the current time of the console and we start the process. So, and this will output 2 times, the one of the console and the one returned by our endpoint handler. And when we subtract the 2, we get the time to the first request. That is interesting. So this was the methodology, right? And for the single REST endpoint application, these are the numbers, right? For the native executable, it's like 14 or up to 20 milliseconds, depending on how fast your machine is. In the JVM mode, it's still very good under a second. And the traditional stack needs a couple of seconds, right? When we add persistence, again, the numbers change, but this is still tens of microseconds, and this is a very few seconds, and this is like 10 or more, depending on how many entities you have. Good. I think there's a question there. I may not say, but as I said with one of the previous slides, it doesn't matter because you get this order of magnitude with any of them. Good. And this is the overall picture. Traditional Java is very fat to be deployed inside a container because it spends so much memory. And for the same amount of money, you can deploy in just a few containers with traditional Java. And that was the reason why in the recent 1, 2, 3 years, many Java developers or companies that traditionally used Java for backend started to switch for Node.js or Go, because the efficiency levels there are much different. And this is what Quarkus is offering, right? That's the efficiency level of Go, basically. Okay, now how it works, but let's have a look. What's the time? We have a couple of minutes. I must get faster. So, how it works? So far we looked only at the Quarkus part, right? At what it produced, right? And now we will look into the technicalities. In a traditional application servers, hundreds of classes are run only during the boot, and they are later unused, and they still occupy the memory and can't be collected for various reasons. But when we are in the container environment, we are not going to redeploy because we just kill the container and start a new one if there's a new version, right? And we can throw away lots of that code for this reason. Things like XML parsers, annotation lookups and processing, management model, lots of things. And that's exactly the idea behind Quarkus. We try to do as much as possible at the build time. And the output of this process is some recorded wiring bytecode that just directly starts the code that really serves the requests. Let's try to explain how this works in the case of dependency injection. So a dependency CDI container needs to do several things to work, right? It needs to find injection points and find the producers and decide which one fits where. And in traditional containers, this is happening during the container start and during the deployment of your application. And this is lots of code and lots of time. And that code costs not only time, but also the memory. And we can switch that off, do it at build time, and hard code how those dependencies are. What does it look like? I hope you can read it. We have two simple user beans, which happen to be applications code, right? There's a catalog that depends on pricing. So the CDI container at build time can produce very easily this kind of metadata, a bean class, right? This is just very figurative. There's no code, no Java code generation like this. It's written directly into bytecode, and it doesn't happen directly like this. This is simplified. But for you to have an idea, this is how it roughly works. Okay. So this encodes the dependencies, and this encodes the call to the post-construct method. It's hard-coded here, right? When we need to create the catalog, these three things need to happen. Okay? That's just a simple single class. And as a part of the main class, there's a static initializer that makes use of these beans, and because these are application scope, they can be instantiated already, so that the lookup into this beans array, what it is, map, doesn't need to happen, and straight away the pricing can be pulled from the application context where the instance is there. Why is this important? We will see very soon why we are doing it in a static initializer. So some of that generated bytecode is written into a static initializer. It's preferred, and it's preferred because GraalVM can further optimize it or make some nice tricks with it. And things that cannot be put into static initializer are put into main method. And which ones are that? Those ones that access resources that are available at runtime only, such as files, sockets, or whatever else. Okay? So this is roughly the architecture of Quarkus built-time container. There are some components at the bottom, which we will skip now because we have no time. And there's lots of extensions. Extensions are the things that add support to a specific technology. CDI, for example, logging, or health, MicroProfile health, right? Every one of them has an extension. There are units of Quarkus distribution, and you will use them as Maven dependencies in your project. So they configure, boot, and integrate the given library or framework, and they make the code light up to run on JVM and make it fit, make some tricks to fit the GraalVM. New extensions are welcome. If you have ideas, or if you want to contribute, this is very good. Just raise your hands on the GitHub project, file an issue, and there's a very nice guide on the Quarkus website. I'm not going to open it because we have no time. That you can follow. And if your idea doesn't get accepted inside the main Quarkus project, don't worry, because extensions can be developed externally. And that's exactly what we do with KM Quarkus. And soon there's going to be support for third-party extensions on code Quarkus.io and in the Quarkus universe bomb that will unify all those. So now let's have a look on how Quarkus works in a minute. GraalVM has two meanings. One of them is the umbrella for those many things, but we'll use just the Graal compiler and substrate VM. To do an ahead of time compilation with GraalVM means you take your application classes, the JDK classes, and substrate VM classes that replace some of those standard JDK classes. And the result is the executable. So there's many fancy things happening there. The most interesting of them is the closed world assumption. GraalVM assumes that all the code that is going to run at runtime is available at build time. This is very strong limitation, but because it's there, many optimizations can happen, such as dead code elimination up to the level of code branches. If GraalVM sees that some piece of code is not going to be used, it's thrown away, and that's how the native executable, that's why the native executable in the end is so small. So this is how we work when you work with plain GraalVM. And these are the interesting limitations. So there's no dynamic class loading, and that's basically why a traditional Java container such as Tomcat or Wildfly can never be ported to Graal, because you cannot deploy jars, vars, and so on, because that's dynamic class loading. There are no native interfaces like this one, which basically means no agents and no Java debugger in the native mode, right? In the native mode, no Java debugger. But in the JVM mode, everything works as usual, and you can debug even with Java debugger. In the native mode, you can debug with the native debugger, which inserts the dwarf symbols, but only in the GraalVM Enterprise. So there's no security manager, which is probably not a problem because you're not going to load any classes. Invoke dynamic is basically unsupported, but the support that is needed for running lambdas is there through replacements in the substrate VM, and basically lambdas run as usual methods. So there's no reflection, but you can register your classes, methods, and fields for reflection. And with Quarkus, you can do it with this annotation. And this is basically what Quarkus extensions are doing for you. If they know that the given framework needs some specific kinds of classes to be reflected, such as JPA entities, it adds them for you. So everything which has entity annotation is gonna be registered for reflection, for example, right? Other things that require upfront registrations are dynamic proxies, runtime resources, such as application properties files, and so on. And many things. So this is the last thing I'll probably say because we are out of time. GraalVM runs all static or safe static initializers at build time for you, and it takes a snapshot of the produced Java heap and copies it directly into the executable. And that's why booting those executable is so fast. There's no class resolution, which is a complex process, right? Many dependencies, and it cannot be, it's serialized, cannot be run in parallel much. And that's why booting Quarkus, booting GraalVM natives is so fast. So, and this is the reason why you cannot put file handles, sockets, and threads into static initializers, because the code is run at build time. Let's skip this because we are out of time. And let's go straight to the end. So it's good old Java, but the efficiency level of Go You are not supposed to learn much because it uses well-established standards, libraries and frameworks, and that makes Java choice #1 for cloud and serverless functions. These are the links. Thank you very much.